Hey, thanks for joining us. In this video, we're going to take a look at the use of cellular concrete on a couple of mocked up pipe abandonments. We did these demos as part of our 2018 Fall Demo Day. We started with the smaller grain sewer pipe and filled it with water, and then used a lightweight cellular concrete to demonstrate the ability to displace water. Next, we took the larger corrugated pipe and placed multiple vent holes so we could watch the flow of the material as it filled the pipe. The first pipe we filled was just a sewer drain pipe, so we left the end open to keep pumping pressures low. After we had the pipe filled with water, we dialed in one of our CT30D crete foamers to produce 40 PCF material. Once we had the pipe filled up, we dialed in the machine to the right density before hooking it up to the pipe. Density was checked using one of our QC field kits. As you can see, once we started pumping cellular concrete into the pipe, clear water started being displaced from it. Given the small volume, the pipe didn't take long for the cellular grout to start appearing. After a few seconds of cellular material coming out of the pipe, we checked the density of the material again to see how much washout was occurring from the water actually washing foam bubbles out of the mix. The density checked out at 42 PCF, which means we really had pretty good consistency. Like we've seen in the field, a cellular concrete that's lower in density than water can push it from a pipe. The pipe diameter and fill rate would no doubt factor into how effectively this could be done, but on this particular demo it worked pretty well. The next pipe we filled was a dry 16-inch diameter by 20-foot long pipe. We cut a series of vent holes in the top of the pipe, and for the purposes of this demo, we were using them as sight holes. We wanted to really be able to see how the material flowed through the pipe. Would it flow along the bottom of the pipe and then rise to the top, or would it fill one end of the pipe first and push to the far end? As with the first pipe, we used one of our CT30D machines, but decreased the material density to about 30 pounds per cubic foot. This is a pretty typical density used on abandonment and geotechnical void fill applications. Like the first pipe, we dialed in the density before hooking it up to the pipe to fill it. And also like the first pipe, this was a pretty small volume pipe to fill, only about 1 1/4 yards. You can see from this angle that first and second ports started having material flow out of it at pretty close to the same time. Of course, not long after, ports 3, then 4 had material coming out too. We were plugging ports as it filled to get material to move towards the end of the pipe. This worked pretty well until port number 4. Taking a look at the material flow from another angle gives a really interesting perspective on how the material flowed through the pipe. As you'll see, this also gave us another pretty good angle of the vent plug on port number 4 popping out. Even so, we did get some material to come off the vent pipe at the end, as you'd see in normal pipe abandonments. For the final part of the demo, we sawed off both ends of the pipe after a few days to check and see if it was in fact completely full. Looking at the pics of each pipe, you can see the fill end is 100% full, and the vent end does have just a bit of a gap at the top. We didn't use a vertical vent pipe on the end or plug and cap it like you'd normally do, so seeing this wasn't too unexpected or concerning. Overall though, we were pretty happy with how both these pipe fills went. Thanks for checking us out.